Hi there. Recently I needed to fix some complicated kitchen plumbing problem, and I thought having a more powerful rechargeable torchlight in the toolbox than the 1.5 volt pen light that I had would have been really handy. So I decided for the next time I'll be better equipped and got this one. I got it from eBay from this seller G4Tune66, and you can buy just the light and the charger. But just for kicks, I ordered it with the 18650 cell to see what they would actually deliver. Equally suspicious is the 90,000 lumens claim. That's almost what full sunlight at a clear sky will get you. No way you can get that out of a cheap LED inside a cheap torchlight. It arrived in the usual shipping envelope, and inside were these two bags, one containing the torchlight and the other the charger. They shipped the battery inside the torchlight, which makes sense since it's well protected. A cardboard disc isolates the battery to avoid accidental activation of the light during shipping. The charger is the USB type for a single 18650. The battery claims a valid capacity of 3000 mAh or 11.1 watt-hours, which, given how light the cell is highly unlikely. It also seems to indicate there's some sort of protection built in, and again there's no trace of that. The other side has the usual warning. I tried to decode the barcode and it appears to be *L3124* in code 128, which according to Wikipedia is used extensively worldwide in shipping and packing industries. A search for the code proved useless, and equally for Gabriel, which seems to be mostly used for torchlights sold on Amazon with batteries of impossible capacities of 5000 milliamps or more. Well, I kind of expected that the battery is probably fake, but let's proceed for now. The open cell voltage is almost 4 volts, so it's almost full. That means I can test if the torch works without having to wait for charging the battery first. Let's put it in. It works very well, and it's extremely bright, more than enough for what I need it for. Although the eBay page did not mention it, it obviously has the usual torch chip that seems to be standard these days. The next scene contains some flashing images, so be warned. Each time you turn it on, it moves to the next of 5 modes: full brightness, dimmed brightness, even further dimmed, headache introducing strobe light, and finally SOS blinking in Morse code. The camera doesn't really show the dimming effect, but it works quite well. Unfortunately, the chip doesn't remember the mode you leave it in, so you always have to endure unwanted modes briefly until you clicked your way to the one you want. With the blinking over for now, the torch sports this label indicating a zoom range of 2000, which is again one of those claims. What it does is widen or narrow the beam by sliding the front lens closer or further away from the LED. Fully focused and directed to a wall 2 meters away, the lens actually projects a fairly clear image of the LED chip itself. The camera is swamped out by the brightness, so if I reduce the exposure it becomes a bit clearer to see. The torch itself is made of what looks like anodized aluminium and can be dismantled into a number of pieces. The lens is actually made of glass. A closer look into the rear of the head assembly shows the spring to make contact with the positive pole of the 18650 and a disc with 2 notches hinting that this ring may be turnable for further disassembly. Using scissors inappropriately, I tried to turn the ring, and the whole thing popped out. Actually, the turning had nothing to do with it. That part is just held in by the friction of the 2 O-rings and of course the counter pressure of the lens cap itself. The LED chip is obviously mounted on some white carrier, probably coated aluminum for heat transfer. The mode controller chip is probably inside. It looks as if the LED actually contains 3 LEDs in parallel, as we have already seen earlier in the image projected at the wall. The rear has this disc which looks as if it could be turned to unscrew, but in fact all you need to do is poke something into the holes and lift it. You see the twisted wires? Those are for my attempt to turn the disc. Luckily I stopped in time before tearing them off. So the brains are not on the inside of the LED carrier board, but on a separate PCB with quite an air gap. That's probably a good decision to spread the heat a bit. Let's have a closer look. The controller chip is a YN05, and unfortunately I have not managed to find a datasheet for it. There's a single capacitor next to a 1 megohm resistor, and then there are just 4 1 ohm resistors. I try to reverse the circuit, which isn't easy because of the black solder mask, and because with such tiny resistances there's no real difference when measuring continuity or through a resistor. I initially suspected the 1 megohm and the capacitor being part of a clock circuit for the chip, but the way they seem to be wired is just decoupling, with the resistor quickly discharging the capacitor, probably to debounce the torch on-off switch to help it detect clean power on-off transitions. Otherwise, contact bounce may cause it to change mode unintentionally. The 4 1 ohm resistors are all in parallel, and the resulting 0.25 ohm limits the current through the LED. To get an idea what currents this small chip is handling, I connected my multimeter in series with the battery. Please be warned that there will be some flashing lights coming up soon. In this setup, the yellow wire serves as the on-off button of the torch. Wow, almost 1 amp of current at full brightness. The first dimming mode reduces that to half, and the second dimming mode halves it again to 235 milliamps. Strobing is probably too fast to register as a full current, but the long pulses of the SOS are definitely full brightness and full current. And back to full brightness. And with that, I think it's time to move from the torch to the charger and battery. The charger claims to produce 4.2 volts at 500 milliamps. It is held together with 4 self-tapper screws. Inside is the usual arrangement of a tiny circuit board and the slider for the negative pole with its spring. Some reasonable strain relief, which is better than the usual knot in the wire. With a bit of wiggling, the circuit board can be lifted out. There's just one chip that does the charging. We can see here 2 LEDs helpfully labeled R and G, which supposedly stands for red and green. The chip is an LTH7, a well-known charge controller. To what extent the PCB labeling can be trusted is questionable. Here we have a resistor labeled 10K, where it's clearly a 100K resistor on the board. Here's the reversed engineered circuit. The resistor connecting to the Brock pin programs the maximum charge current. With a 2K resistor, that will be 500 milliamps, exactly as promised. The 2 LEDs caused me some confusion because initially I believed the labeling on the PCB, and according to that the green LED is the one connected to pin 1 of the chip, but that would not work at all. In the end, I plugged power in, and now you can see for yourself that the LED labeled R is actually the green one. I really wonder who made this board and whether the wrong labels are accidentally or intentionally as some kind of anti-piracy measure. To demonstrate why this circuit only works if a red LED is driven by the chip, I made this little breadboard mock-up of just the LEDs. Like in the actual circuit, both anodes are connected and shared a common resistor 2+. The cathode of the green LED is connected to ground while the red cathode is open, simulating that the chip is not charging. If I pull the red cathode to ground using the white wire, the red LED lights and the green one goes off. The reason for this is that the red and green LEDs have different forward voltages, with red LED voltages being quite a bit lower than the green ones. To show, I connected the multimeter to the common anode of both. You can see the green LED has a forward voltage of 2.5 volts. If I pull the cathode of the red LED to ground, the red LED lights and its lower forward voltage drops the common anode voltage to just 1.7 volts. That is too low for the green LED and so it goes off. As expected, the charger draws 500 mA while charging the battery. The red light is a bit hidden. At the end of the charge, the current drops to basically just what is needed to drive the green LED. And the end of charge voltage is 4.14 volts. Initially I charged the Gabriel battery using the provided charger till full, then I discharged it using my electronic load at 1 amp constant current with a cutoff voltage of 2.5 volts. That provided 1228 milliamp hours, less than half of the promised 3000. I then charged it again until full and repeated the discharge process as before. That netted 1231 milliamp hours. So I think it's conclusive that the battery is a fake or possibly a worn out recycled battery with a new sleeve. To find out, I removed the sleeve, although that renders it unusable in the torch because its metallic body in contact with the torch's body shortens the on-off switch. Interestingly, there's a faint code of sorts written on the body. The camera actually picks this up better than the eye. I read it as HL20I24 1200J-05. I did a research for that, but I did not find anything useful. If anybody can shed light on this, please leave it in the comments. In summary, the charger and the torch are quite nice, although I could do without the torch's blinking modes. Don't bother buying the battery. If you liked the video and would like to see more, consider subscribing, and now you can also become a Patreon to get early access to all my videos as well as exclusive content. There's a link in the description of the video. Thanks for watching.